In this video, we're going to go over a slightly more challenging yet classic type of direct variation problem. And I'm going to remind you of the type of thinking that I like you guys to do when really given a problem where you're like, I don't know what to directly do here. The answer to what do I do is really only coming from a place of, well, do you know how to do it or not? The answer to what can I do is, well, I could do this, so let me try what I know that I could do. So what can I do is a great question, or what could I do? And we're going to ask that here. It says y varies directly with x. I'm going to stop right there. If y varies directly with x, we know that that means y is k times x. That's what that first sentence tells us. It then says if y equals -8 when x equals 2, and I stop there because I'm asking myself, what can I do? Well, they're telling us, I'm telling you, I made the problem up, y equals -8 when x is 2. What we could do is plug in -8 for y and 2 for x and figure out what to do from there. So let's just do that. So that means that -8 is y when x is 2. So we're now left with an equation. So what else could we do? Well, we could solve for k. Let's keep doing that, noting that we stopped here in our reading. I'm going to divide both sides by 2, and that leaves me with k is equal to -8 divided by 2 is -4. Oh, nice. Let's keep reading. Then what is the direct variation equation? I think we found it, right? We have k equals -4. We have y equals k times x. So the equation would be y equals -4 is k times x. So by asking what can I do, we've just translated as we've read a problem rather than just memorizing, oh, this is this kind of problem where I always do this step and this step and this step. It's a much more powerful way of thinking. So now that I have that equation, we're then asked to find y when x is 5. So don't memorize what to do. What could we do with 5? We could plug it in and that would give us y, our answer. So y is equal to -4 times 5. -4 times 5 is -20. So y is equal to -20 when x is 5. And there you have it, folks. We've solved the problem, translating it one little piece at a time. On the flip side of the video, I've got a slightly more challenging problem that actually ends up being very similar to what we just did. It's just all in the wording and seeing how to translate it. Stoked to see you on the flip side. And here we are on the flip side of the video. We've got a slightly more challenging problem, but don't be scared away. It's just the way that the words are arranged. So let's dive into it and tackle it. Y varies directly with x. Immediately, stop your reading, make the translation based on the knowledge you have. Y is equal to k times x. That's direct variation relationship. The points 8, 12, and x18 work in this direct variation relationship. And we need to find x. Well, if these points work in this relationship, remember that points on a graph are also values that work in the equation that describes that graph. So what I mean by that is x is 8 when y is 12. X equals 8 when y is 12. That's another way of interpreting that point. When I plug in 8 into this equation, I'll get out 12. Why don't we plug them in and see what k is? So 12 is y when x is 8. Again, another example of us asking ourselves, what can I do with the information I have, and just rolling with it and discovering what happens rather than memorizing what to do. So now I divide both sides by 8. And I'm left with k. So the 8's divide out. 12 divided by 8 simplifies when we divide the numerator and denominator by 4. We get 3 halves. So k is equal to 3 halves. And let me embolden that 3. So now what I have is this equation of y equals 3 halves x. So whether or not I'm asked for that equation, it doesn't really matter. It's that I found it, and that's a little more information than we started with. Then we're told that the point x18 also works in that relationship, and we want to find x. Well, if this works in this relationship, that means I can plug in those values into it and expect the equation to be true. Well, I want to find x. Let's see how this presents us with how we can find x. 18 is the y value. It's the second coordinate in that ordered pair. That's equal to 3 halves, still times x. It's like we're plugging in x for x. But we have an equation where we could solve for x, and that would give us what the x value is, which is what we want to find. So to undo multiplication by a fraction, we multiply both sides by the reciprocal, 2/3. So I have to do the same thing to both sides. 2/3 times 3/2 cancels out, leaving us with x. And 18 over 1, if it helps you to simplify, we can do it that way. 3 goes into itself once and into 18 6 times. 6 times 2 is 12 over 1, which is just 12. And that's it. Hey, we found x. Another example of just asking yourself, what can I do with the information, and translating as you go along, rather than saying, let me memorize what my teacher did in class. Not a good way to learn math. What can I do? A lot.